Coming up, Tanaz, if you can please share your slides. So Tanaz Jamilpanah, if I butchered the pronunciation, I apologize, is a biology major who loves to bake and also coaches and referees basketball games on the weekends. Awesome. Tanaz worked with Dr. Professor Eric Gross, along with postdoc Freeborn Ruer.
Is my
And
microphone on? I'm not sure.
yes, we can hear you.
Okay, cool.
Who are part of Stanford University. And Tanaz will be presenting flushing caused by ALDH2 alcohol metabolism enzyme.
Yeah, so my project is characterization of novel ALDH2 variants that causes alcohol flushing in humans. I was at the Eric Gross lab at Stanford Hospital, and my direct mentor was Freeborn Aware. Just kind of as an introduction, I'm a first-year biology student. I plan on transferring fall of 2024, and my favorite aspect of this internship was just seeing like real-world applications of the things that I was learning. I think that it's pretty rare to, learn something in class and a few days later or later that week, you go in somewhere and see how it's actually used by, researchers in a lab. Just some key notes. Nearly 560 million East Asians have a defect in aldehyde dehydrogenase 2 that limits their acetaldehyde metabolism. ALDH2 is the major enzyme that metabolizes acetaldehyde to acetic acid following alcohol consumption. Variants in this gene can lead to acetaldehyde accumulation due to inefficient metabolism, and ultimately this accumulation is carcinogenic and can cause DNA damage and development of cancer. So kind of like a big picture question is, have you ever turned red after drinking alcohol? So what I was looking at is, do ALDH2 genetic variants identified below metabolize acetaldehyde efficiently? This can affect whether or not a person may turn red. Inefficient alcohol metabolism increases the heart rate, which is why people will flush. So these are the three variants that I was looking at. They're color-coded here, and they belong to East Asian, South Asian, and Finnish ethnicities. So during this project, I learned how to express, purify, and characterize ALDH2 enzymes. Freeborn helped me with the transformation of plasmids in bacterial E. coli and protein expression. I harvested the cells and broke them down with a lysis reagent. The proteins were purified by Freeborn with a nickel affinity column here. And I ran a 10% SDS gel, just gel electrophoresis, to determine the purity of the proteins. If it's not the purity that we want, then the protein purification process has to be repeated. Finally, I ran a protein assay to determine the activity of our enzymes using a UV Weiss spectrophotometer. So this is kind of like a way to visualize like what's going on in our body. We start off with ethanol, which is oxidized to acetaldehyde as an intermediate by alcohol dehydrogenase, which is ADH, and acetaldehyde then being oxidized into acetic acid by ALDH2 is specifically what we're looking at in the lab. In this phase, NAD+ is converted to NADH. And an important thing is that if there's a deficiency in ALDH2's ability to catalyze acetaldehyde, then acetaldehyde levels increase in the bloodstream, consequently increasing its toxic effects. These are just some pictures of me in the lab. On the right, you can see I was just measuring out the things that I need to do to put them in a cuvette and put them in the spectrophotometer. And it gave me a graph of the reaction rate, and the slope of it was the rate of the specific enzyme that I was looking at. These are the results from the 3 variants that I was looking at, as well as the wild type. You can see, obviously, the wild type has the highest activity, and the E504K and R338W not so much in terms of like metabolizing acetaldehyde. And the next step in that was, well, there's a drug called ALDA1, and we asked, okay, well, does ALDA1 enhance the activity of the wild type and its variants? So ALDA1 is an ALDH activator that stimulates acetaldehyde oxidation through increased NAD binding. In my findings, there were dramatic increases in the activity of the wild type as well as the T244M variant. There was a slight increase in activity with the E504K and no effect at all with the R338W. I believe, yeah. So just going back and forth, if you look at the axes, you see that, they've increased a lot. Even the E504K had a slight increase, but not that much. And these two just had a really significant increase. So the conclusions that I was able to draw from this was that R338W and E504K are novel ALDH2 variants that do not efficiently metabolize acetaldehyde to acetic acid. And ALDA1 significantly activated the wild type and T244M, but did not significantly activate the E504K and R338W variants. Sort of like the what's next in my project. So my results contributed to the overall project goal by, I was able to conclude that the ALDA1 activator is not a universal activator of ALDH2 and only significantly activated the wild type and T244M variant. And what will be done next with the work that I've done so far is that we will use 3T3 cells to further characterize the variants. Sort of my reflection in this, the key skills that I gained were preparing assays, coding in MATLAB, and operating Excel and Sheets, which I've had no experience before. So it was pretty cool to see how much more than what I already knew, like it was capable of doing in terms of like creating like functions and stuff like that. Major challenges that I faced were being able to successfully repeat tasks with minimal error. I had said this before in one of our seminars, but I think it's really hard as kind of like a beginner in this field to be able to keep repeating tasks over and over again and just making sure that you don't make mistakes, because one small mistake can just mess up your results for the whole trial. And also having steady hands, always being careful and remembering to take safety precautions, especially in my case because I was working with E. coli. And some key takeaways were that these tasks that I was doing come naturally to those that work in the field of medicine. I'm extremely grateful that I was exposed to this kind of pressure so early on, and it inspires me to work hard so that I can make my own contributions to science with a team of my own one day. And I would just like to take a moment to thank Freeborn, Eric, and the Gross Lab, and of course the SLI program for giving me this opportunity, and specifically thank you, Sophia and Marissa. And that is my project.